Hello, my name is Eli Windsor,
I am Bennett Meyer,
And I'm Adam Latito.
and I'm the team lead for Flyboys 2.
and we are the ASME student section at NC State's IAM3D competitive team.
And this is our UARCV, the Flying Wolf. Hey everyone, I'm here to show off the Flying Wolf. As you can see, we've gone through a couple different design iterations. We first started out with the lower chassis with an EM holder on the front to pick up the blocks and slots to mount DC motors on each side. This first design only included a small area to mount a camera underneath, which proved to be insufficient. After we completed the wiring for the UAV, we realized that we needed more areas to mount a voltage stepper and 2 MOSFETs, as you can see here on our final iteration, which led us to the second iteration. This design turned out to be faulty when after a few flights, we crashed and bent 3 legs outward and sheared one of them off. This led to our third iteration, where we've added a cross-sectional support beam as well as a connecting underarch between the left and right legs to reduce bending under the weight of the UAV. We also removed the sidewall supporting the electromagnet to allow for a faster print. The next piece that went through a few iterations were the arms. In this first one, you can see the caster mounting was much too small and failed during the print. We changed to this design, where the casters mount to the 2 holes and the motor mounts up to the top like so. The wheels also went through a small change. We added more tread to increase traction on the driving wheels and took away the tread from the front wheels to reduce friction while turning and allow us to easily maneuver on the ground. The last thing we want to mention is the battery holder. During a flight, the Flying Wolf took a hit and bent the holder, causing these mounting tabs to shear off. We combated this in our new design by adding a crossbar connecting each side to add more support and reduce the bending that individual legs endure. Our first interesting and unique design elements of our UARCV is the drivetrain that we have implemented on the lower body of our craft. It has 2 motors controlling the rear wheels, each wired to a MOSFET to allow them to be controlled from the receiver. The 2 MOSFETs are then wired to a voltage stepper that is pulling voltage straight from the battery and stepping it down to control the rotational velocity. These 2 motors underneath the chassis aren't the only thing that we find nifty. The electromagnet mounted to the front of the chassis allows us to pick up the payloads using a small camera mounted behind. The addition of a drivetrain allows us to easily maneuver and pick up blocks as well as diminish the downdraft that scatters the blocks around. It also provides an extremely effective form of landing gear by reducing the stress on the main body, as well as allowing us to roll on the ground during flight rather than hitting a rigid body. Another interesting feature of our design are these caster wheels we've mounted underneath each arm to deflect any stress the arm may endure when coming in contact with the walls of the drop zone. So rather than hitting and damaging the arm, the casters allow the arm to roll over the wall. This has been extremely useful in practice when a payload gets pushed up against the wall of the pickup zone, and the only way to pick it up is to drive right up against the wall. Normally this may harm the arms or the motors, but the casters ensure that we can do that, bringing no harm to the craft. The third and final design element that we thought to be pretty nifty is this attachment we've added to allow us to wire 2 batteries together in parallel to double the capacity available and giving us a longer flight time.